Let's discuss random variables. A random variable is a numerical variable whose values depend on the outcome of a chance experiment. So the way this works is you can think of an easy example, like let's roll a die. If we roll a die, we know all the possible outcomes of a die can be 1, 2, 3, 4, 5, and 6. And we know that those probabilities for each roll is going to be 1/6. The only thing we don't know is what the actual roll is until we do it. We generally define a random variable with a capital letter X. And there are two types of random variables, just like we have two types of data. The first type of random variable is a discrete random variable. Just like you have discrete data, remember, discrete data is any data that can be counted or anything that can be measured with whole numbers. So if we have to count our data with whole numbers, we're going to get discrete data. And it's a discrete random variable. The other type of random variable is called a continuous random variable. And that results when you measure data, when you have interval values. So let's look at a couple of examples and see if we can identify the difference between a discrete random variable and a continuous random variable. So look at the first example. Notice how it says x equals. We always define it as x equals something. And this it says x equals the number of Fortune 500 companies that lost money in the previous year. So the question we should ask is, can that variable be counted or can that variable be measured? And because the key word here is the number. The number tells me I'm going to count something. So I'm counting the number of Fortune 500 companies, and they have to be whole numbers. So because of that, this is going to be a discrete variable. The next one says x equals the volume of gasoline in a 21-gallon tank. Can that be counted or can that be measured? So when we think about that, the key distinction here is the word volume. And we know volume is a unit. Units of measurement means that this is a continuous variable. The speed of a rocket. Again, speed is a unit of measurement. So because that's a unit of measurement, this is also continuous. And the last one says x equals the number of calves born on a farm in 1 year. Well, the number of calves born, can you have a fractional number of calves born? Probably not. You have to have a whole calf or it's not. So because you have to, when you're counting that and it says the number again, that tells me this is going to be discrete. Now, we're going to focus more on the discrete random variables in this particular unit, and we'll get to the continuous ones later. And for a discrete random variable, we create what's called a discrete probability distribution. And it's going to list all the possible values that can be associated with the random variable along with their probabilities. For instance, like we said earlier, let's roll a die. So we'll let x equal the roll of a die. But what are all the possible outcomes when I roll a die? So when I make a table, we generally put this in a table form. It's called a probability distribution table. And we say x, and then our values of x, well, x can be, when you roll a die, x can be 1, it can be 2, it can be 3, 4, 5, and 6. Those are all the possible outcomes. And then we associate a probability with those outcomes. We call it P of x, the probability of x. Well, the probability of rolling a 1 when you roll a die is 1/6. A 2, 1/6. A 3, 1/6. 4, 1/6. 5, 1/6. And 5, and 6, 1/6. So those are all the possible outcomes and every probability associated with each outcome. And now we develop our general rules that we have for probability. The same way we do with probability, we're going to develop them for random variables. And what that means is there's two rules we're going to focus on. Those rules are, the first rule says the probability of each event must be between 0 and 1 inclusive, meaning that this probability here can't be negative and it can't be bigger than 1. And we can go ahead and verify this in this distribution with the roll of die that we created. We can see that all these probabilities are 1/6, so they all are positive probabilities and they all are less than 1. So that part of a probability distribution checks out for us. The second rule is that the probability of all events must sum to 1. And this notation, sigma notation, says that if we take sigma means to sum, if you add up all the probabilities of x's, they should equal to 1. Well, we do it here. 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 is equal to 6/6. and 6 is equal to 1. So this is a valid probability distribution. And this is a discrete variable that we've shown in a probability distribution table. And so let's go and look at these examples and explain why or why they aren't valid distributions. So if we look at the first one, well, here's what we're going to check. We don't really care about the x. We don't really need to know about the x values. What we're interested in are these probabilities. And they have to meet two conditions. They all have to be either positive and less than 1, or the other condition they have to make is that they all have to add to 1. When we look at this first set, these are all positive and less than 1. But as we start to add them up, let's add them up. 0.28 plus 0.13. That's 0.41. So we're good there. Plus 0.43 again, 0.84 plus 0.15. Well, this right here, the sum of the probabilities is equal to 0.99. Well, what's wrong with that? Well, these have to sum to 1. So is this a valid distribution? No. The probability of x's do not sum to 1. Look at the next one. Well, the next one says you have -1, 0, 1, and 2 for your x's. And again, x's don't matter. They can be negative or they can be positive. We only care about the probabilities. Well, are all the probabilities positive? 1/2, 1/4. Oh, look what we have here, a -1/2. So we already know that, again, no, the p of x cannot be negative. So these distributions both are non-valid because one doesn't sum to 1 and the other one is not has a negative probability.